let's get started on Tuesday. I hope you guys had a good break. We are looking at 10.8 diagramming data. We're going to be here for a few days because there's a few different things that are wrapped up within this one section. But today we're going to be looking at the box and whisker plot. Before we learn about the box and whisker, we need to learn some definitions. So the first fill-ins here, and let's talk through these definitions. We have the blank quartile, we say that word as quartile, is the median of the lower half of data, and that's the lower quartile, and I'll explain this more in context in a second. The blank quartile is the median for all of the data, so we say this is the middle quartile, and again, I'll explain kind of what this means as we go through. And then we have this last one, which is the upper quartile, and that's the median for the upper half of data. So what you see here, this is a box and whisker. You may have learned about this before. If you haven't, we're going to learn about it today. In a box and whisker, you notice it is comprised of a box, and these parts out here are the whiskers. Now this is a visual representation of data, just like the bar graph, just like the line graph. Now I have a lot of students that look at this and it looks completely different, kind of like a foreign language, and it is very different. But it is just another way to represent data. And in fact, many of the tests that you guys take, standardized tests, your results come back in a box and whisker format. And we're not taking them this year, but if you look back at prior results, and in the future, you'll know better how to read your own results. So in a box and whisker, you can see what is included in it. So at the bottom of it, or to the far left, is the smallest value, and to the right, or the top of it, we see the largest value, okay? So you'll be given a set of data, and we'll put the smallest down here, largest up here. All right, not too bad so far. Then we see the lower quartile, the upper quartile, and the median. Now another word for median here is the middle quartile, which is the definition we were given up here. So middle quartile is the median for all data, and you can see down here they just use the word median. We'll just throw the word middle quartile in here as well. Okay, so let's jump into an example, because right now I'm going to guess is not making tons of sense. So let's start making sense of what we're doing. So example number 1. Our goal is to make a box and whisker, okay? And we learned back on the other side that we need 5 things, right? We need the smallest value, and this right here says upper extreme. Upper extreme just means the greatest value. I just didn't change that. It means the same thing, but if it's more helpful to see greatest value, I'll write that in. And we're going to find the median, the lower quartile, and the, ooh, what did I do here? Oh, this here, sorry. I'll edit this as we go through. Smallest value, this should be the upper quartile. Somehow that got changed. And you can't see what I'm writing. Upper quartile. So we're given a set of data. The very first thing we need to do is order the data. And that's what we've had to do before. So the smallest value I see here is 2. Bring that down. I see a 3 and a 3, so I'll bring both of those down. I'm crossing them off so I make sure I do not lose anything here. Then I have a 4, 5, 6, and 8. All right, I've got them all brought down. Now we're ready to fill in these 5 things. So first of all, smallest value. Very simple. What is the smallest value here? Well, it's 2. All right, coming down here, we're going to switch around a little bit. Largest value. Well, the largest value here, all the way to the right, if we order them least to greatest, is going to be 8. Okay, now there's one other word we know here, and that's median. Median means what? Middle number. And you guys already learned how to find this, so let's do that. Often we used crossing off, and you can use that. Just be careful not to cover up your number. So I may just make a mark below it. So we'll say low, high, low, high, low, high. So we have 3 below and 3 above, and we have our median. So the median of this data is 4. Now we're going to find the upper quartile and the lower quartile. Now the definitions, if we look back, said that the upper quartile is the median for the upper half of data, and the lower quartile is the median for the lower half of data. Well, how do you know what's the lower and what's the upper? Well, once you have found the median And here, because it's just one number, we didn't have to average two numbers since it's just one number, we take the numbers to the right of it, and those are the upper set of data. And the numbers to the left of it, or the lower numbers, this is the lower half of data. Now our answer to lower quartile is not 2, 3, and 3. All right, we're going to, and remember the definition, let's just use the definition, lower quartile is the median of the lower half of data. So looking at this lower half of data, 2, 3, and 3, how do you find the middle of it? Well, let's cross it off this time. Low, high, there's only 3 numbers, right? So you can see right here, we have found the median of the lower set of data, and so that is 3. The last thing we're going to write down here is the upper quartile. Remember, I had some problems there at the beginning. Upper quartile. So that's the median for the upper half of data. And we marked it up here. This is the upper half of data. Notice we did not include our median in it. If it helps you, you can cross it off and just focus on the lower and the upper. Now, looking at our upper, again, we have 3 numbers. It's always going to be the same on both sides, right? Because it's split in half. And then we have 5, 6, and 8. So low, high, and that just leaves 6 as the median for the upper set of data. So now we have found all of these values. The smallest value is 2, the upper quartile is 6, the median is 4, the lower quartile is 3, and the largest value is 8. Now we are going to take that information and convert it into a box and whisker. So I want you to keep these notes handy because they're going to be really helpful as we set this up. Now you notice, okay, I'm going to scoot down and we're going to work on this number line. So you're going to have to look back at your data, okay? But you guys can see your own data. You've got it written down. If you didn't write it down, go back, rewind, and copy it down. You should be copying with me, writing along, and figuring as we go. So first of all, I'm just going to mark all the important parts. The important parts are the smallest value, the lower quartile, the median, the upper quartile, and the largest value. So, starting with my smallest value, it's 2. Now, we do not write directly on the number line. We're going to write above it. So, the smallest value is 2. Then, the largest value, and we can kind of go in whatever order we want. I'm going to skip around a little bit. There's the smallest value. The largest value, according to our work, was 8. Then our median, which is what we found next, you have to find median before you can find upper and lower quartile. Median was 4, so we'll put a point there. We're not going to just leave it as points, but that's how we're going to start. And then our lower quartile is 3, and 3 is down here. So I'll put it straight above that. And then the upper quartile was 6, so above 6 we'll put a point there. Now notice, the box is on, so we'll create 3 lines on the lower quartile, the median, and the upper quartile, or the middle quartile, we can say instead of median. So on those 3 points, so the lower quartile, we'll put a line there. On the middle quartile, we'll put a line. And on the upper quartile. So on all of those quartile points, we'll put lines. And then we connect them into our box. And then we also, you notice those whiskers, we connect to the smallest value and the largest value. So coming back over here, we're going to connect to the smallest value and the largest value. And we have now drawn a box and whisker. Now let's try another example. We're given a set of data here. We are going to find those same 5 things. You notice instead of the words smallest value and greatest value, we're using the words minimum and maximum. They mean the same thing. Okay, so if you'd like to, you can write next to them for minimum, smallest value, and for maximum, largest value. But it should be pretty intuitive. We know what those words mean. So without further ado, let's find these 5 values. And you'll notice the data set that I've given us here is already ordered. So we can find the minimum and maximum very quickly. The minimum, or the smallest value, we can see all the way to the left, is 12. And the maximum, or the largest value, is all the way to the right at 31. Okay? Now remember, we must first find the median before we can find the upper and lower quartiles. And again, we have this type. So starting with that median, we know how to find median. It is that middle number. We can use crossing out to do that. I'm going to use a pencil so I can still see the number. So low, low, high, low, high, low, high, low. Now we have high. We have 4 numbers down here and 4 up here. So we actually have 2. When we have 2, what do? We should average them. So we're going to take 19 and 22 and we will add them up and do what? Divide by 2, right? So 9 plus 2 is 11. Carry the 1. 1, 1, and 2 give us 4. So we have 41. We need to divide that by 2. So we have 41 divided by 2. 2 goes into 4 twice. We subtract. We're left with 0. 2 goes into 1 0 times. Add the decimal point in 0. Bring it down. 2 goes into 10 5 times, and it does go evenly. So we get 20.5. So that is our median, right? Now, you'll notice this data set is a little different. In our previous problem, it had an odd number, so there was only 1 median, and then we just excluded it, right? Well, in this example, if you have 2 numbers as your middle numbers and you have to average them, what you do is you chop it right down the middle, and this set over here, including the median, this lower median, we're going to call this the lower set of data, and then we'll include this number that we use to factor in our median with the upper half of data. Okay? So if there's only 1 median, you just exclude it, like in our previous problem. If there are 2 where we have to average them together, we split it down the middle, and the lower one goes with the lower set of data, and the larger one goes with the upper set. Now let's find upper and lower quartile. Starting with the lower quartile, we're just skipping around here. No particular order. You just have to do median first. Lower quartile, so looking at this lower half of data, it's the median of these numbers. Well, there's 1, 2, 3, 4, 5 numbers here. So we're going to find the middle of those. Now you may know 2 below, 2 above, we'll put 17 in the middle, but you can also cross out low, high, and your lower quartile, or median of the lower portion of data, is 17. Then moving to our upper quartile, we again have 5 pieces of data. It should be the same on each side, and we know that it's going to be 29. And so we have our upper quartile. Now from here, we are going to create our box and whisker. So let's do it. One question I didn't... Let's draw our box and whisker. First of all, let's draw the number line. Now in this problem, they didn't give us a number line. We're going to draw our own. That number line is not part of the answer. It just helps us keep our work organized. So we see numbers as low as 12 up to 31. I'm going to count by 5s on my number line, but you could do whatever you want here. So we'll do 5. These need to be an equal distance apart. 10, 15, or as equal as possible, 30, 35. Okay, so first I'm going to plot these 5 above it, and again, we're not putting it on the number line, so our minimum is 12. So a little past 10, we'll put 12. Then we have 29, so nearly to 30. Then our median is 20 Oh my goodness. Okay, so now we're ready to draw our box and whisker. Before we do that, we're going to use a number line. Now, in the previous problem, I gave you the number line. In this problem, I'm going to have you draw the number line. The number line is not part of the answer. It just helps us keep our work consistent. So, draw your number line in, and I'm going to cut it into pieces. I'm not going to count by 1s. We won't be able to fit because it goes all the way to 29. I'm going to count by 5. So we have 5, 10, 15, 20, 25, 30, and we'll put 35. Okay, so these are pretty equal distant, so we'll use those. So first of all, I'm going to plot my 5 points. So we have the minimum is 12, the upper quartile is 29, so nearly to 30, I'll put a point. Median 20.5, so we have 20 and just barely past it, almost unnoticeably. Lower quartile is 17, so in between 15 and 20, it'll be closer to 15, but a little ways over there, nearly half, right? Half would be 17 and 17.5, so just go a little bit off-centered. And then lastly, our maximum is 31, so a little past 30. Okay, so now we're going to draw in those 3 lines on our lower, middle, and upper chordal, and then connect it into that box. From there, we connect our minimum and our maximum. So looking at this box and whisker, we can see that the data is definitely shifted high here. Notice it's very close to the maximum, okay? So the data is more concentrated in the higher spectrum. We can also see that this is a fairly long bar in relation to the length of our whiskers. So we would say the data is fairly spread out as well. So that is our lesson.